Hello folks, Dave Mayo here from HackYourGut.com, and today we're going to talk about meal timing. There's actually a couple really interesting studies that were published that confirm a lot of the things that we already knew, as well as kind of discovering some new things as well. Very, very interesting stuff. As you're all probably aware, I'm big on circadian rhythms. And this just shows about how important layering of circadian exposures and circadian hormone output is important for regulating homeostasis within the body. So what we're really going to talk about now is something that a lot of people are aware of, something called insulin sensitivity. So insulin is a hormone that kind of helps regulate our blood sugar levels. So when our blood sugar levels begin to increase, our pancreas identifies this and secretes a hormone called insulin, which causes insulin-sensitive tissues such as the liver, fat cells, and muscle cells to take that excess glucose out of the blood and into the cell. So it's a very, very important hormone. The counter-regulatory hormone to that is called glucagon. Glucagon causes our liver to pump out the glucose that it has stored to bring our blood glucose levels up when they drop too low. But this recent study took a look at meal timing, specifically dinner timing, and how different dinner timings affect our body's response to the food that we eat. So what they did was they compared individuals. They had one experimental procedure where people were exposed to 75 grams of glucose, which is an oral glucose tolerance test, either 4 hours prior to bed or 1 hour prior to bedtime. And they took a look to see, hey, what does this look like? Is there a difference between the blood glucose levels and the insulin levels in these individuals? And what they found was the people who consumed, when people consumed that 75 grams of glucose 1 hour before bed, they had higher blood glucose levels and lower insulin levels than the people who did it 4 hours before bed. Now, this is important because we've known for years that our insulin sensitivity is higher during the day and lower at night. And what this basically shows is something's acting as a brake on our insulin levels at nighttime. And as it turns out, it's melatonin, which is another circadian hormone. Melatonin is effectively a hormone pumped out by our pineal gland that increases when we are no longer viewing light in general and blue light in particular. So during the day, when we're getting plenty of light in our eye, we inhibit melatonin, and then at night, when we're not being exposed to this light, we actually start making more melatonin. So what they found was that as melatonin levels increase, this melatonin binds to melatonin 1B receptors in the pancreas and actually puts the brakes on our insulin secretion into the blood. It doesn't completely stop it, but it decreases it a substantial amount. And what they found is when people consumed 75 grams of glucose an hour before bed, their blood glucose levels were 8% higher than people who consumed the same oral glucose tolerance test 4 hours prior to bed. And what they found was melatonin was inhibiting insulin by around 6% in these individuals. And so this just kind of goes to show you how these different exposures regulate our blood glucose level. Melatonin blocks insulin. Insulin will not lower blood glucose, which, we're about to go into a fast as we fall asleep. So we wouldn't want our blood glucose levels crashing. We also wouldn't want to pump out cortisol to help elevate our blood glucose levels while we're asleep, because that would wake us up from sleeping. So study just kind of confirms that melatonin's doing this. Interestingly, there are polymorphisms in the melatonin receptor that actually cause this effect to be greater. So when melatonin binds to this melatonin 1B receptor in people with a G allele as opposed to the CC homozygous genotype, they actually have a stronger inhibition of insulin, which means if they eat later at night, they're going to have higher blood glucose levels and lower blood insulin levels. And this is actually interesting when we look at another new study that was recently published. And what they found was that at sleep onset, we have this very interesting phenomenon where the blood-brain barrier actually starts pulling glucose out of the blood. And this is regulated by the master clock in the brain. So that master clock's the same thing that's regulating melatonin release. So what happens at night is the blood-brain barrier becomes more permeable to glucose, and then this glucose goes into the brain, and it actually decreases our blood glucose levels. So we wouldn't want to have insulin secreted into our blood at this time because it could cause our blood sugar to crash. It's really cool stuff, and it just goes to show you how many different layers of circadian rhythms and different quote-unquote clocks within the body are communicating with one another. You have the master clock in the brain, you have the peripheral clocks with insulin, with the pancreatic cell secreting insulin, you have a liver clock that's regulating glucose output, you have the adrenal clock. So we have all of these things that can have a major impact on how our body regulates blood glucose levels. And so, you know, when blood glucose levels drop, we're going to get that, you know, increase in cortisol, which causes glucagon to make the liver pump out glucose and increase our blood glucose levels. So these are different exposures. You have stress regulating glucocorticoids, which is cortisol. You have feeding and what we eat, you know, and when we eat, and how all of this plays a role in regulating something that is that has so many moving parts within it, such as blood glucose levels and blood glucose regulation. So these are some really cool studies. We are so amazing. You know, I know a lot of people kind of look at blood glucose regulation as primarily how many carbohydrates are you eating, and this just goes to show you that, you know, you can get away with eating a much more substantial amount of carbohydrate during the day than you do at night. And so you probably don't want to have that late night snack, you know, eating potato chips or whatever late at night, a high glucose meal. You can regulate carbohydrate content, not necessarily the total carbohydrate intake, but when you're eating your carbohydrate. Another interesting factor on this is when our amino acids kind of increase in our blood after we eat, insulin actually helps increase muscle protein synthesis. So this actually kind of upholds this evidence that we had. It's in mice that muscle protein synthesis is higher in the day, but that's because we can pump out more insulin during the day because we don't have melatonin acting as a brake on the amount of insulin. So again, we can look at the amount of carbohydrate that we eat, the amount of protein that we eat, and when we eat these things, and we can get, you know, even better results when we time these things and we are making sure that we are getting the proper light exposure, physical activity, increases in body temperature, our feeding, you know, with insulin seeming to act as at least one of the food entrainable oscillators, meaning that it's one of the hormones that our body uses to identify when our feeding period is. So really cool stuff. If you're looking for the basic take home here, if you want to eat a higher carbohydrate diet, eat the carbohydrates earlier in the day. If you're looking to maximize muscle protein synthesis, again, you want to eat a lot of protein earlier in the day as well. And because, you know, at night you're not going to get as much of that insulin secretion to kind of help bolster muscle protein synthesis. So that's basically what I do. Breakfast and lunch, I get most of my carbs and a much higher protein intake than I do at dinner, simply because you're utilizing it more effectively during the day. So thank you very much for listening. As always, if you have questions, comments, or what have you, put them in the comment section below. If you found this interesting and you want me to do more videos like this, like, share, comment, or share on social media. Thank you very much. Take care.